Thank you, and thank you also for inviting me. I will give a brief overview of what we do with GCOS and what the relevance is for Copernicus. And just a bit of personal memory or history. In 2007, I was asked to chair the GMES group on the global land monitoring. And during that meeting, there were two important things. One was that at that time, there was talk about a new series of satellites, and that the satellite data would only be accessible to those involved in the GMES projects, so not publicly available. Those of us in the group almost stood up and said, "Thank you very much, that's not what we want. It's either got to be publicly accessible or not," and I'm very glad that that happened. The second one is that we were asked to produce a set of variables that were useful to monitor. And during the meeting, we realized that there was a program called GCOS that had already done a lot of the homework for that. And so, in short, how do we develop the requirements for programs like Copernicus and C3S? That was because GCOS had already defined these ECVs. That's history. But what it shows is that there is a very important feedback loop. What GCOS does is we try to address the variables that are needed. And initially, we did that on the basis of how mature they are, how relevant they are for climate research at that point in time. It was still an issue whether climate was changing in '92 when the program started. Oh, this is, I want to go back one. Yeah. What Copernicus does is at the bottom side is take those data and deliver services. And I think Carlo already mentioned that the feedback between those two is a very important element. We wouldn't be able to define our ECVs as being useful if we didn't have the feedback of programs like Copernicus and C3S. And vice versa, C3S, of course, likes to have these sort of programs from us. Taking the next slide, that'd be easy, I think. Just leave it, probably don't touch it too much. What we do is we try to provide as much as we can in terms of needs for climate data. And as I said, initially that was very much a monitoring aspect. Can we determine where the climate is changing, where it's changing? And there are quite some changes now in the demand on the data that is being asked of us. We identify those in ECVs, essential climate variables, and essentially they comprise physical, chemical, and biological properties of the Earth system. They are, I think we have 54 of them now, and each of those has a number of products associated with that. So it's like opening a book and then going into a sort of Russian puppet and getting further and further down into the data stores. We have a revised MOU coming up soon. So we started in '92 when it was together with the UNFCCC. The program was established. In '96 we had the first plan. In 1998 we started reviewing. You need to be able to assess the status of the observing program before you can identify what is needed next. And then there's a whole series of these plans. It goes a little bit anti-clockwise here. And the last one is just being submitted to the UNFCCC only 2 days ago. Within that, we want to have a system that is fit for purpose. And it's important to realize that GCOS doesn't run observation systems. What we try to do is monitor the amount of the observation systems and how well they do what they promised. The GCOS 22 implementation plan is different from previous one. It's readable. It's much shorter than particularly the previous one, and it's also more focused. We try to address the stakeholders who need to respond to the action. So we're asking groups like ESA with the CCI, with the C3S of Copernicus, and space agencies to perform specific tasks. The way we do that, and to some extent, I think that's part of the success of GCOS, but also why we're proud of it in a way, is that we have a status report that's being produced by a lot of people, experts in the field. We have 3 panels, ocean, land, and atmosphere. Then we consult all these panels and the expert what is needed. We draft a program that's being put out for public review. That happened earlier on in this year, so there's a lot of comments being given to the program, being given to the report. We take those comments and respond to each of them very carefully, a similar way as IPCC does. In fact, we use their same system to keep track of the comments. We revise it, and then it's published. So it will be published probably sometime this week on the website. It was, as I said, it's just submitted to UNFCCC only yesterday, I think. What is changing is also the demand for specific types of data. While we could get easily away with low resolution, for instance, temperature data in the past, now we need high resolution data. We need that data to be able to predict. We also need those data to make adaptation programs. Particularly adaptation programs are very sensitive to the type of data that you use. And it's a changing perspective that you need probably to zoom in into specific areas where you need high resolution data, not only in space but also in time. And we are always very closely linked to the UNFCCC. What we also do, and I think Carlo also mentioned this, is we monitor the cycles. We don't necessarily monitor them for the scientific interest. Of course, a lot of us are scientists, so we are interested in the science. But we use the cycles also to see how well we understand the system and if there are specific variables that we miss. And we do that for the carbon cycle, the energy cycle, and the water cycle. We published 3 papers, and there's an update on the energy cycle paper just coming out, which generates the Earth energy imbalance. And from that paper, we also take specific advice on that. We need to invest in some satellites continuity missions to be able to get the Earth radiation budget, for instance. Similarly, one of the reasons to get a good satellite for greenhouse gas or CO2 observations is also one of those exercises. So monitoring the cycles gives us also a handle on how well we understand the Earth system and what needs to be monitored more deeply. This is the new IP, and I just want to go on the left. You see what's the input of that. I already mentioned some of that. The new thing now is that we grouped our recommendations. So we have about 40 tasks, and those are grouped under ensuring sustainability. So it's making sure that the observing systems keep on working, that there are no budget cuts in specific countries which suddenly drop synoptic stations by half, or things like that. What Gerard already mentioned also with the SOF, the financial facility for improving those things, relates to filling data gaps. There are still large areas in the world where we don't have data. There are still large areas in the world where we don't have the necessary boundary of the radio soundings. That is what the SOF is trying to fund. Managing data, improving the data quality in established data centers. C3S is a prime example of where that goes really well. We have ECV specific centers that look after the data, like the Glacier data center in Zurich. They need to do that with a high level of quality control, and of course they are improving on that continuously. Managing the data, engaging also with the countries. How well can we get the countries on board? In fact, the SOF came out of one of the GCOS workshops that we held with small Pacific Island countries on adaptation. And so keeping in touch with those countries is really important. And of course, we want the new things that are coming on the block. We would like to include those as well. So those 6 themes are big now in the IP. You see them here, listed in a little bit more detail. I won't go into that, but it's, to some extent, there is also a bit of a classic litany of worries. Hydrological data is not being supplied. People measure it, but it's not available. A lot of those things we try to stimulate, and we also use WMO as a big organization to try and get that funded. But there are also other issues like the emerging needs, the higher resolution data that I mentioned. Some of the things that are particularly relevant for the new missions are monitored here. I tried to play this. A particular worry for us is, and that's not because I'm now director of an Institute for Sea Research, is that a lot of the ocean observations are very short-term funded. They're project-based, research-based fundings, and they're not really sustained in a sustained manner. And that goes for ship-based measurements in particular. So we really need to pay attention to an integrated ocean observing system, and we do that with GCOS, the ocean observing program. There are some really big game changers in the ocean observing, like the Argo floats, of course, but there is still a lot to be done, and it needs to be done as well. So I mentioned that we want to get people to act and organizations to act. Here on the left-hand side, you see the specific groups that we're trying to address. And we're trying to make specific versions of the program that are relevant for the space agencies, specific versions that are relevant for the implementing agencies like Copernicus and in situ observations. A few things about Copernicus. Thanks, of course, for supporting the Secretariat. The Secretariat is vital in all these things, in bringing people together, organizing meetings, and producing reports like this. We've had many interactions. Carlo was involved in the writing team of the IP. A lot of people provided expert advice, gave comments on the IP during the review station, so we had that also. And I'd like to give you one final thought, is that GCOS and Copernicus and C3S, we do have a shared history, and that has worked very well in that feedback loop that I showed you at the beginning. But importantly, I think we also have a responsibility. We have a responsibility to keep on doing that and doing that well. That's for the kids that we put on this world. Thank you.